We are going to be talking about quadratic functions during this chapter. Quadratic. It's actually not, no. A quadratic function is a second degree polynomial. Oh, you can. You know what? You realize that through about half of chapter 7, you are working with quadratic equations.
Wow. Interesting.
Like think about your x squared plus 5x plus 6, and you factored it. Okay. Now, what we're going to expand on is the graph of this. Okay. So when we have a quadratic function, it is going to give us a parabola. A parabola. Looks kind of like a U. Yep. Desmos. Okay. So when I ask you to graph a quadratic function, it's going to look like a parabola in some way, shape, or form. Now, throughout the course of this week and next week, we're going to talk about how it will move around and change shapes and all of that kind of stuff. Okay. But let's talk about, bless you, some characteristics of a parabola. Looks like a U. And there's one point right here that we call the vertex. Do you remember when we did absolute value equations? We had a vertex. Remember? Okay. Now, what do you notice? Is this a symmetrical shape? Yeah. Okay.
Sure.
It has symmetry. That is not a very good vertical line. Well, it's supposed to be symmetrical, Sophia. Okay. Didn't take you very long to get that in. Okay, so we have what's called an axis of symmetry. Okay, through the vertex, we can draw a vertical line that cuts our parabola in half. Yes.
One side is
Okay.
it's non-linear.
It is not linear. You're right.
That means it's a line.
Linear means line.
It's very non-linear.
Okay, so let's do this. Let's talk about the graph of x squared. When I plug in 0, what is 0 squared?
0, 1.
When I plug in 1, what is 1 squared? What else squared is 1? What about when I plug in 2? And -2 is also 4. That better? Thanks. Okay. It goes on forever. All right. Preston, where is our vertex?
0, 0.
Okay. Our vertex is at 0, 0. Where's our axis of symmetry? The y what? Y-axis, how do we write that as an equation? Let me tell you, it's x equals 0. We can also say that our parabola is decreasing and then increasing, right? It falls and then it rises. Tell you what, I put a Desmos link in your Google Classroom. I'm going to give you a couple minutes to play around with what I put in there for you, so you can tell me what happens to your graph when you change the coefficient of x squared. It makes it what? Probably not.
So neat.
Okay, so in Google Classroom, there's a link. And graphed is ax squared. And I want you to tell me what numbers for A, how they affect our graph. Yes, that's me. Sophia, that is unacceptable. Okay, so here is the normal. Here is the normal, y equals x squared. This is what we just graphed. What can you tell me about when we change A? Okay, how do I get that to be really skinny? What kind of number would I need for A? Okay, describe it to me. A number bigger than what? a number bigger than 1. Any of these numbers that are bigger than 1 are going to make our parabola skinnier. Okay, so what happens if my number is smaller than 1?
It's bigger than smaller.
Okay, it gets wider. So like look at 0.1. Look at how wide that is. Okay, now what happens when I go below 0? So a negative a made it flip upside down. Okay. All right, if it's 0, we no longer have a quadratic. All right, go ahead and close your computers. Okay. This is what I want you to write down about our observation. Go ahead and go to whatever this page is, page 248. If the absolute value of A is bigger than 1, then our graph is going to be skinnier. Okay, but if the absolute value of A is less than 1, then our graph is going to get wider. Okay. We graphed what we would consider the parent function, y equals x squared. If we change the coefficient, we're going to get skinnier or wider. And if A is negative, that parabola is going to flip upside down. So you need to be able to tell what the heck is going to happen with a parabola before you graph it, okay? You need to be able to describe to me, this one is going to be wider or skinnier than x squared. This one's going to flip upside down compared to normal. So what can you tell me about the A for this graph? Is the A positive or a negative? It's a positive, and we know that because what? It's going up. How about over here? What do we know about the A for this? It's going to be negative because our parabola is flipped upside down. Now let's talk about number 2. Where is the vertex in this shape? Okay. Our vertex is at 3, 4. Okay. What about our axis of symmetry? How would we write it? I like the 3, but I do need it to be an equation. X equals 3. Since it is a vertical line, we need to write the equation x equals 3. Okay. Reagan, everyone else was thinking that. You were brave enough to say it. Thank you for that. All right, so let's go ahead and go to this next page. G of x equals 5x squared. Thank you. All right. Jaya, what do you think? Is this going to be skinnier or wider than x squared? Is 5 bigger than 1 or smaller than 1? 5 is bigger than 1. And what did we write down? If our number is bigger than 1, it's going to be? The alligator is eating. Okay. Okay. This is going to be skinnier. So that's what we're going to do. Since we are only changing the coefficient of x squared, I know that our vertex is going to be at 0. Okay. So I'm going to draw my X and Y axis here. Okay. What happens when we plug in 0? Okay, we get 0. Now, what happens when we plug in 1? What do we get? 5 times 1 squared. 5. Okay, now we can kind of see the skinny, right? What happens when we plug in -1? We get 5 again, right? Now, if it works, I would love for you to be able to plug into a -2, but when we plug in 2, we get 20, don't we? Wait, yeah, right? Not crazy. Well, those aren't going to fit on our graph. So there's our graph. Skinnier than, now I don't want you to draw this with me. This in pink would be y equals x squared. Okay, so notice how at 1, we stretch from the 0.11 to the 0.15. Do you think there's a correlation there? You don't think that 1,1 to 1,5 has any significance? Okay. Fine. Any observation about number 4? Okay, Sophia says it's negative, which means our parabola is going to be upside down. Okay, what else do we know? Okay, it again will be skinnier than x squared because 4 is bigger than 1. The negative makes it flip upside down. The 4 is going to make it skinnier. Okay, so will you, for me, please, plug in these 5 numbers for x? All right, when we plug in -2, what do we get? -16, right? Yeah. What about -1? What about 0? Yes. What about 1? What about 2? Okay, you should have a pattern. Because we have an axis of symmetry, like if this guy is my vertex right here, then there should be a pattern on either side of the vertex. Okay, So whoops, that's not what I wanted. Okay, here is my vertex at 0, 0. On each side of the vertex, you have that pattern of having the same y value. Now, I walked by Preston, and without making a chart, he had these points figured out. Did anybody else? How'd you know? Yeah, by what? Okay, so normally we had the coordinate 1, 1, right? Well, it became 1, 4 upside down. What about number 7? You have a smirk on your face. Oh, fractions are our friends.
I mean, the camera comes to cooking.
That is true, Abby.
They're always our friends. Okay, so let's make some observations. What do we know about this graph before we even graph it? Amelia. Okay, well, I heard somebody blurt out it's upside down. What about the 1/5? What is the 1/5 doing? Okay, it's going to be wider. Okay, 1/5 is smaller than 1. It is a fact. So it is going to be wider. Okay, so when I plug in 0, okay, we get 0. It's what all of your vertex points are going to be at 0, 0 today. Okay. Now, what happens when we plug in 1? What do we get? We get negative 1/5, don't we? And I don't know about you, but I don't really want to graph 1/5 and then 4/5 and then 9/5. What is maybe a number we could plug in that wouldn't give us a fraction? Oh, let's plug in 5. When we plug in 5, what is negative 1/5 times 5 squared? What? Try this again. Negative 1/5 times 5 squared. Negative 5. What about negative 1/5 times negative 5 squared? A negative. So notice how much, oh, that's terrible. Notice how much wider our parabola is than if we were to have like this would be negative x squared. So notice how much wider it is. Sure. You and your elbow partner need to come up with the answers for 9 and 10. You have 30 seconds, and then we're going to talk about it. Go. Always, sometimes, never. For 9 and 10, you have 30 seconds. Okay. Look at me for instructions. Always is one finger. Sometimes is 2 fingers. Never is 0 fingers. Always, sometimes, never. What do you vote for 9? Always, sometimes, never. Always, sometimes, never. I'm seeing always and I see sometimes. Okay. If A is greater than 0. Colin, give me a number greater than 0. Would that make it wider? What's another number greater than 0, Elliot? Would that make it wider?
Yes.
Yes. So this is a sometimes. It really matters if it's bigger than 1. Okay. All right, the graph of g of x, a equals x squared, is narrower than the graph. Okay. Always, sometimes, never. Vote. It would be never. This would need to be greater than 1 if you want it to be narrower. Less than 1 is going to be wider. Yeah?
Yeah.
Okay. So, oh, I didn't give you your gold sheet yet. You need your gold sheet.